Today we are working on graphing something called parabolas. Now parabolas are a U-shape graph. Like if you think about like Angry Birds, if something's being thrown, that's in the graph of a parabola. Or we could have it the other way. And so the way you can tell if something is a parabola is because it has this little squared here. Okay, so what we're going to do is we are going to start with something called the parent function. It is f of x equals x squared. So what this does, this is what causes a graph to be a parabola. So sometimes these are called quadratics. The graph of a quadratic is called a parabola. Okay, so what we're going to do is we're going to take this f of x equals x squared, and we're going to do a t-chart. Now, whenever we have the f of x, that just means a y. So this is like graphing y equals x squared. So we're going to just put some numbers in for our x. We can pick any numbers we want, but since we're on this graph, we want things that are going to be able to fit on the graph. So maybe we'll start in the middle, we'll put a 0 and a 1 and a 2, and then we'll have a -1 and a -2 as well. So what we're going to do is we're going to take that -2 and plug it in for the x. So what if we have a -2 in parentheses, and then we square it, we're going to have -2 times -2, which gives us a +4. So we would have the point -2, 4. Now we're going to have the same thing if we have a -1 and we plug it into the equation. We put the -1 in parentheses, and then we square it. This means -1 times -1, which equals a 1. Now 0 squared just means 0 times 0, which is just equal to 0. And 1 squared is 1 times 1, which is a 1. And 2 squared just means a 2 times 2, which is a 4. Now we're going to take all of these points and we are going to graph them on our graph. So if we have the point -2, 4, we're going to go to the left 2, 1, 2, and then up 1, 2, 3, 4, and this would be the point of our graph. Then we have the point -1, 1. We go to the left 1, up 1. We have the point 0, 0. We have the point 1, 1, and the point 2, 4. Now we're going to take these and complete the curve. We just join them together to make our parabola shape. Now the domain has to do with the x's. What x's could we put in here? Now we were just picking random numbers, but there's no restrictions on the x. I could pick any x and it would work. So we're going to put on domain, we're going to put all real numbers. I could put a pi in there, I could put a half or a fourth, any number I could square. The range has to do with the y values. Y is we're going to start at the bottom and see where it goes. So it's starting at the point 0, and then y will continue to go up. So y is always going to be greater than or equal to 0 on the graph y equals x squared. Now the highest or lowest point on the parabola, right here is the lowest point. This would be called the vertex. Now if I'm going from left to right, the graph is decreasing and then it's going to increase again. So it is increasing on the right side when the x is greater than 0. So here's the x. When x is greater than 0, it's increasing. And when x is less than 0 over here, it's decreasing. So I'm going to put x is less than 0. And then at 0, it's like kind of half increasing, half decreasing. So we wouldn't ever put equal signs on here. Now we have this dotted line in the center. This is called the axis of symmetry. And it's always just in the center of the parabola, and it divides the parabola into mirror images that passes through the vertex. The vertex is always on top of the axis of symmetry. This is the equation of a parabola. This is called vertex form of a parabola. If you switch the sign of this number in this form, it's going to be an H. And then this K stays the same. So what's going to happen is if I have a negative number here, it's going to become a positive number. And if I had a positive number here, it would become a negative number. So it's just going to flip the sign of whatever number is here for the vertex. The axis of symmetry is always at the H. We change whatever number. So if it was a negative number, it would change to a positive number. If it was a positive number, it would change to a negative number. Now, parabolas, we can tell if they open up or down by this number here. If A is positive, the graph is going to open up. So one way you can remember that is if you have a positive A, it makes a happy face. If you have a negative A, it's going to make a frowny face, and open down if A is negative. So let's look at an example on the next page. We're going to graph this f of x just means y equals negative 2, x plus 1 squared minus 3. So because this is a positive one, we're going to have it's going to flip the sign. Okay, so anything with the parentheses changes signs. Then we have this minus 3. This number makes it go down 3. So this negative 3 stays the same. So we have the point negative 1, 2, 3, and that would be this point right here. Now the axis of symmetry is always on top of this number here. So we have a negative 1, we have this dotted line right here, and that represents the axis of symmetry. Now every single parabola use these key points that we can get from the original parent function. If 1 squared is 1, 2 squared is 4. So every time I'm going to start from the vertex, and I'm going to go over 1, up 1, and put a point, and then over 2, up 4, and put a point. So I have these points 1, 1, 2, 4. So what I can do is I can make a little t-table of 1, 1, 2, 4. But I have this negative 2 here, and this is our stretch. This is our vertical stretch. And so vertically has to do with the y values. Okay, so this number is going to take all of our y values and multiply them by a negative 2. So I'm going to have, instead of over 1, up 1, I'm going to take 1 and times it by a negative 2, which gives me a negative 2 there. And 4 times negative 2 gives me negative 8. So these little square brackets, like pointed brackets, those are not points. So I'm not going to go over 1 and down 2 from the origin. I'm going to start at the vertex and go over 1 and down 2. And that would be where I would get my next point. So from the vertex, over 1, down 2. And then my second one is over 2 and down 8. Okay, so I get this point and this point. I have my axis of symmetry here, which tells me I'm going to reflect those points over that axis of symmetry. So it's going to be the same distance on both sides of the axis of symmetry. And then what you do is you just complete it by connecting the parabola into a smooth curve. So we're going to start by sketching a graph of the function. We want to start by shifting our graph. So the number in parentheses, it does the opposite of what you think it's going to do. So I have a -4, that's going to go to a +4, and then -6 here is going to go, is your up and down value. So this number here has to do with left and right. This number here has to do with up and down. So we're going to go +4 direction, but that negative is going to stay -6. It's not going to flip the sign. And you know that because it's not in the parentheses. If it's in parentheses, it does the opposite of what you think it's going to do. So we have our point. It's at 4, 6. Sorry, 4, -6. Axis of symmetry is going to be on top. If you count over, this is 1, 2, 3, 4. This is the line x equals 4. Okay, now we're going to use our key points. Our key points are 1, 1, 2, 4, but we have a 3 in the front. So this is our vertical stretch. So what we're going to do is we're going to take that 3 and vertically, that has to do with the y's. Y's go up and down, so we're going to take our 3 and multiply it by our 1 here and our 4 here to get 12. So from the vertex, we're going to count over. We're going to start at the vertex. We're going to go over 1 and up 3 and then put a point. Then we're going to start from that vertex and go over 2 and up 12. And then we reflect those points over the axis of symmetry. And then we just do our best to make a nice smooth curve that's in a parabola shape. You can put the arrows on the ends to make sure that you know that they go on forever. And then we're going to talk transformations. Well, we look at the equation and we always want to just go left to right. We have this vertical stretch by 3. We went this -4 has to do with the left and right. We went to the right 4, and then we went this -6 had us go down 6. Okay, domain has to do with what numbers we put in for our x's. Our x's, we can always, for parabolas, they always go forever to the left, forever to the right. You can put any number in for x. So we're going to just always write all real numbers on all of the domains. Okay, but the range is different. So the range has to do with up and down. If you notice, the parabola is up here, but there's nothing down here. So it's starting at -6, and then it's going up forever. So the y has to be higher, greater than -6, greater than or equal to -6, because -6 is part of the graph right here. Okay, looking at number 4, we're going to start with the vertex. We take whatever number is in here and have the opposite. So if we have a +3 in the parentheses, it becomes a -3, and then the +2 is just up 2. So we want to start by putting a -3 and +2, and we put that vertex on the graph. The axis of symmetry always just goes on top of our vertex. It's the line that divides it, and it's always this first number, x equals -3. That's where our vertex is. We're going to take our key points of 1, 1, 2, 4, and we're going to multiply by our a value. So that's 1/2. So I have half of 1 is 1/2, half of 4 is a 2. So over 1 up a half, and over 2 up 2. And then we reflect that over the axis of symmetry. Now when you're doing homework, it just needs 1 point, but it has to be a whole number. So that's why we need this second number. We need this over 2 up 2. That's the point you're going to put on your homework. This 1/2 won't work. You have to do it in whole increments. So we need this number here. Okay, transformations we want to take and go left to right. Now if something is 1/2 of the size, it got smaller. Okay, so if something's half of the size, we started big, it went small. So this is a vertical shrink, and it got 1/2 the size. So we're going to put that on transformations. Then we have this +3, that made it go left 3. And then the +2 has us go up 2. Range, we start at the 2 and go up. So it's the y is everything greater than or equal to 2. We have our vertex. We're going to start by that +2. It's in parentheses. It's going to do the opposite of what you think it's going to do. That +2 is going to go left 2 and then up 5. Put our point, left 2, up 5. And then our axis of symmetry is always on top of the vertex. So we just put in dotted lines there. Our key points are our points 1, 1, 2, 4. We take our a value of -1/4 and times it by 1 to get -1/4. And then we take 4 and times it by -1/4, and that gives us a -1. So when we're graphing this, we start from our vertex right here. We go over 1, down 1/4. Now you're not going to be able to put this point into the computer, so we need another point. Go over 2, down 1, and then reflect that over the axis of symmetry. And that'll be enough to graph it on the computer. You start by graphing the vertex right here, and then you need one other point. This will be your other point. You can put it here or here. Your vertex is our HK. It's this point right here. We have the point -2, +5. Remember, if it's in those parentheses, it's going to switch the sign. So we have -2, +5, and the x is going to be at -2 for the axis of symmetry right here. Our transformations, we go from left to right. Now we have this negative, and what this negative did is it made it go upside down. It went down here, where all of these positive numbers are going up. So if it has a positive number, it's making a happy face. But if it has a negative number, it makes a sad face. It's a reflection over this x-axis. It makes it, instead of that parent graph going up, it makes it go down. So we can abbreviate this as ROXA. But what ROXA means, it's a reflection over the x-axis. But we can abbreviate it as ROXA. This +2 right here, that made it go left 2, and the +5 made it go up 5. Okay, our range is starting here. We have 1, 2, 3, 4, 5 is what the highest point. So it's everything below 5. Y is going to be less than or equal to 5. We have this 1/2 x plus 3 squared. Now notice it's missing this up and down part. It's missing something. So it's not going to go up and down at all. So what it's like we have a plus 0 here. So what happens is this makes it go left 3, and then this is up 0. So left 3, and that would be our vertex at -3, 0. Our axis of symmetry is going to go right on top of the vertex. So this would be at x equals -3. And then we're going to use our key point still. 1, 1, 2, 4. And we're going to multiply by the number in the front, which is 1/2. So half of 1 is 1/2. Half of 4 is 2. So from our vertex, we can go over 1 up 1/2 and over 2 up 2. And then we connect it into a smooth curve. Transformations, if it has a half, what happens vertically, it went half as high. So it's a vertical shrink because it's half the size. Vertical shrink, and it's by 1/2. It also has a left 3. It went left 3 units. Now it did not go up or down, so we're gonna just put we're not going to put anything for the plus 0 because that didn't do anything to the graph. Now domain is all real numbers, and then the range, it's the y values. The lowest y value is 0, and then it goes up. So everything is greater than or equal to 0. Okay, now we're also missing something on number 7. We have a negative. We have inside the parentheses, there's nothing there. It's like a 0 squared plus 5. This is another way of writing the same thing. So if you don't have anything in with the x, it's going to be it's not going left or right at all. So it's just going to go up 5 we'll start at 0, 0. So this is the point, over 0, up 5. Our axis of symmetry is going to be right on top of the vertex. So this is the line x equals 0. And then you get that number from here. Our let's finish graphing it. Let's do our 1, 1, 2, 4. All parabolas have this base, but then you multiply by this -1. So we have 1 and times it by a negative, which is a -1, -1, and 4 times -1 is -4. Over 1, down 1, over 2, down 1, 2, 3, 4. And then we reflect it over the axis of symmetry and complete the graph into a smooth curve. Okay, start from left to right with our transformations. We have a negative. The negative in front made it go down, so it reflected it over the x-axis, and remember we abbreviate that as ROXA. And then we have this plus 5, which made our graph go up 5. Okay, domain is all the x numbers. Those are all real numbers. One way you can write it is this fancy R symbol. That just means all real numbers. And with our range, the y values, the highest point it goes to is 5. Everything else is below the 5. So we're going to say that y is less than or equal to 5. Now this one, it's missing 2 things. So if I have my graph, I have a 3, and then I have no number inside the x with the x squared, and then I have no number up and down. So what this one does, it just stays at 0, 0, and then my 3 is my a value, so that's the number I'm going to multiply by the key points 1, 1, 2, 4, and then you multiply by 3. 1 times 3 is 3, 4 times 3 is 12. Over 1 up 3, over 2 up 12 is off our graph. Axis of symmetry is going to be right on top. And we just draw in a smooth curve to make a parabola. My vertex is at 0, 0. My axis of symmetry is at x equals 0. And the only transformation I have is that 3 in the front, which is a vertical stretch by 3. The domain is all real numbers. I'll put my fancy R there for it. And then the range, it's everything above 0. The lowest y value is 0, so I'm just going to say y is greater than or equal to 0. You do not have to use key points to graph a parabola. You could always use a table of values to do so as well. Okay, I'm going to use the points -2, -1, 0, 1, and 2. So if I were to plug these points in, I'm going to take that -2 and plug it in for the x value. So I'll have -2 times -2 plus 1 squared minus 3. This gives me -2 times -1 squared. -2 plus 1 is -1 minus 3, which gives me -2. -1 times -1 is a positive 1. Minus 3, and then -2 times 1 is -2, minus 3 gives me a -5. Now if I put a -1 in, 0 minus 3 is a -3. Now if I put a 0 in, notice I got the same answer here and here. If I put a 1 in, -2 times 4 is -8, minus 3, 8 minus 3 is -11. Okay, now this last one, I'm going to take my 2, -2, and plug it in. I have 2 plus 1 squared minus 3 is -18, minus 3 is -21. And then I can go ahead and plot these points. I have the point -2, -5, -1, -1, 2, 3, 0, -5, 1, -11. And then everything else is going to be off the graph. But I do know that parabolas have an axis of symmetry that goes through the vertex. That's going to be the highest point. And then this is going to reflect over just like it did before. So if you look at page 54, this is that same point, that same example, but we used just plotting points. We just used a table of values to do the same thing, but we got the same graph if you look at that. On example 10, we are going to write an equation in vertex form for this graph. Now, if you notice, we have our vertex is at -2, +6. So we went left 2 and up 6 units. So I know that inside the x, it went left 2. That's a -2. So in the parentheses, it does the opposite of what you think it's going to do, which is going to be a +2. And then it also went up 6, so we have a +6. Now there's going to be an a value. I'm not sure what that a value is, so I'm going to put an a there. And then that's going to equal my y value. I'm going to put a y here. Now it gives me one other point. Now they could give me any point on this graph, and it is going to follow this equation if I plug in this for x and y. So this is just an x and a y graph, but there's lots of different ones it could be. So this is not a permanent point. These x and y are going to be part of our equation, but what we're going to do is we're going to use this x and this y value to be able to solve for a. So in for my y, I'm going to put in -2. I don't know what my a is. My x is going to be a -4. And don't forget your squared, I forgot that. And then we have a +6. We start with the inside the parentheses. -4 plus 2 is a -2. And then we square that. -2 squared is a +4. That's -2 times -2, which makes it a +4a plus 6. -6 from both sides. We get -8 equals 4a. Divide by 4. And -8 divided by 4 is a -2. So our a value is going to be a -2. So we're going to take that -2, plug it in for the a, and we'll have y equals -2 x plus 2 squared plus 6. And that would be our equation of this parabola. Number 11, we have the vertex here is at 3, 5. So every parabola in vertex form looks like this: x minus h squared plus k. And this is our vertex is our hk. So we're going to just plug these numbers in. We're going to plug these ones in for our x and our y. So in for our y value, we're going to put in -3. We don't know what our a value is. Our x value is going to be 7 minus our h value, which is 3. Notice the sign just changed from a +3 here to a -3. We have a squared and then plus k, which is 5. The sign does not change on this number. Start with what's inside the parentheses. 7 minus 3 is a 4 squared plus a times a plus 5 equals a -3. 4 squared is 16a. We minus 5. We have -8 divide by 16. And then the a is equal to -8 over 16, which reduces to -1/2. So we can write our equation. We have y equals a is -1/2 x minus our h, which is 3, squared, and our plus 5. And that would be the equation of a parabola with a vertex of 3, 5 that went through the point 7, -3.